and welcome to my YouTube channel where every episode I take a physics topic and really try to explain it in a simple and understandable way. Now some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. I've done a key stage 3 episode all about the basics of an electrical circuit. I explained what an electrical current is, what potential difference is, and what resistance is. And I also finished up with explaining the equation that connects them all, which is V equals IR. That the potential difference equals the current multiplied by the resistance, where the potential difference is in volts, current is in amps, and resistance is in ohms. Today, however, I'm going to talk you through the 2 different types of circuit. So let's begin with the series. A series circuit is when you have all the components connected in one circle. So you just have like one straight line running from the positive end of the power supply through to the negative end. You have the power supply, which will be supplying potential difference. So this will travel through the ammeter, which will be measuring current, ran through the resistor, which will be providing some resistance, and back all the way to the negative end of the power supply. In a series circuit like this, if you disconnect just one of the components, the entire circuit breaks. Now this is not very convenient at all. That's why hardly anything is connected via a series circuit these days. Apart from fairy lights. Have you ever had that at Christmas where the whole set of tree lights won't turn on? So you have to go through and check every single bulb individually and find the one that's broken and replace it. That is a tough shift. Like I explained in my basics of a circuit episode, in a series circuit, if you add more batteries, so you add more potential difference to the circuit, they literally just add up. In a series circuit, the total potential difference is V total equals V1 plus V2 plus V3. You get the picture. And this total potential difference is shared between all the components. Sharing is caring. The current is the same everywhere. So if you have more than one ammeter in your series circuit, they should all have the same reading. So, the general equation for current in a series circuit is I1 equals I2 equals I3. And the total resistance in a series circuit is calculated by summing the resistance of all the components in the circuit. Much like the potential difference, the total resistance in a series circuit is calculated using R total equals R1 plus R2 plus R3, etc. However, be careful, because it might not just be the resistors providing the resistance. Certain other components may provide their own resistance too. And lastly, if you want to add a voltmeter into your series circuit, then you have to add it in parallel. Now don't worry if this doesn't make sense yet, because I'm about to tell you right now what a parallel circuit is. A parallel circuit is where each component is connected separately to the power supply. So you have like multiple loops coming down with a component connected between the positive and the negative end of the power supply. The only exception to this is ammeters. They will have to join and be in series with another component. Parallel circuits are better because if you disconnect one component, it hardly affects the rest of the circuit. Those fairy lights. For example, you can have the power supply and then in the first loop you can have an ammeter and a light bulb. Then, separately, but also connected to the same power supply, you can have another light bulb connected in parallel. So you connect a new second wire to the power supply at both ends. Voltmeters also have to be connected in parallel. So if you want to measure the potential difference across light bulb number 2, then you'll have to add in the voltmeter in parallel to this light bulb connected to either side of it. Each of these like mini circuits in our parallel circuit are called branches. So right now on our first branch we have a light bulb and an ammeter, and on our second branch we have another light bulb with a voltmeter in parallel to it. So in a parallel circuit, the total potential difference is the same on each branch. Basically, each component is able to receive the full potential difference. So, V1 across the first branch is equal to V2, which is equal to V3, etc. So this will mean that all the light bulbs in a parallel circuit will receive the same voltage and will be of equal brightness. And then the current. So the total current in a parallel circuit will be all the currents on each branch added up. So I total equals I1 plus I2 plus I3. So in a parallel circuit, the branches act as junctions for the current so it can split off. But the total current entering a branch is equal to the total current leaving. The amount of current that flows through each branch depends on the component. But if the exact same components were used across the two branches, so like in our example, if the exact same two light bulbs were used, then the current would split in half and each component would have the same amount of current running through it. Yay! Share the love! And lastly, resistance. Now it may seem odd, but adding a second resistor into a parallel circuit reduces the total resistance. Right, so this is a bit discombobulating, but stick with me. So all the branches are getting the same potential difference because they're all connected to the same power supply, so that is a constant. But current can split off into the different branches. So if you add another resistor, you're adding another branch that the current can go down, which will increase the total current in the circuit. And using the equation V equals IR, where V is a constant, we can see that if I increases, the R will decrease. So adding another resistor into a parallel circuit will decrease the total resistance. And that's it! The basics of series and parallel circuits. Thank you so much for listening. I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I'll try to have a video for you.